Bruh. Hello, gamers. Um, Hi, everyone. Hi, Georges. Oh, hope everyone is having a great Wednesday. Oh, let me... I always forget to put the desktop in Do Not Disturb. Sadly, web browsers still emit sounds, which is very annoying. But yeah. Yeah, everything's going fine here. It's been a pretty eventless Wednesday for me. I've been doing a little bit of cleanups around the house. Oh, hi, Martin. I mean, I assume you're Martin. The nickname kind of gives it away. Oh. Oh, did you read Oshinoko? It's great. It's so weird. It starts off completely in a direction that I did not expect at all, and then just turns into this interesting analysis on celebrity and idol culture and other things, and I did not expect that to happen at all. I was completely blindsided to it, but it's great. Oh yeah, I have my so I only have a couple there on the back. The rest of the collection is off to the other side of the room because that's where I have room for them. It's kind of hard. I don't know if I can move the webcam. Let me see if I can do it. Oh, there. And that's my pile of things to build. Yeah, it's kind of it's blobbing out. I actually stopped getting new models because the pile is it's not taller than me, but it arrives at my, like, I don't know, around, I don't know if you can see it, but it really arrives right below my shoulders, basically. Oh, hi, Ivano. Yeah, that's a lot of stuff to build. Well, it's not entirely stuff to build. There are a couple of boxes there that are empty, and I just need to find the time to disassemble them and put them somewhere else because they occupy a ton of room. Yeah, I mean, I read them weekly from the fan translation website, so I'm always up to date. But the author of Kaguya is it basically, I think, sometimes takes like a couple of weeks between chapters. So you read a chapter and then you have to wait a couple of weeks. We are in the middle of a 2 weeks break, so it's hard. Also, apparently, Aka is an avid Apex player as well. That's why he knows all about Discord, he knows all about VTubers and gaming and all the other stuff. So, for those who are not aware, Georges and I are talking about this manga called Kaguya-sama. In English, is Kaguya-sama Love is War. And the author is it's basically a nerd. Yeah, he knows about OBS as well. Well, most VTubers use OBS, and most like streamers use OBS anyway. So he knows how it works. He does sometimes. I think he streams as well, but I have no idea where. He's on the like over there on the Japanese YouTube / whatever. So, but he is fairly aware of the technical side of streaming and doing stuff like that. But yeah, I actually strongly recommend this manga. Is great, and there's also an anime series that has been going on for a couple of years. This year there should be a third series of the anime, and yeah, there's also live action drama. Hi, Saptarshi. But yeah, it's a great comedy series that takes a lot of fun out of the tropes of rom-coms and stuff like that. It's so hilarious. So I strongly recommend reading it and watching the anime. You can find it in the manga is published, and you can probably find it in various translations. The anime is also on. I don't want to say like stupid things, but I think it should be on Funimation. It doesn't matter. All streaming websites have now been consolidated into basically like 2. So if you're watching anime, you know. I'm not gonna point people to like illegal websites. Jumping live action is unsettling. It is true. Live action is really weird. I saw. What was the last live action I saw? I saw Watakoi. Love is Hard for Nerds. It's a manga and also an anime, single series anime, and it has a live action adaptation. It's a single movie, I think, and it was so cringe. I couldn't finish it. I arrived like halfway through and I was like, no, cringe. But on the live side, on the live action side, I can recommend the tokusatsu series like Kamen Rider and all that massive media conglomerate. And I also I watched, this was years ago, I watched Blue Blazes, Aoi Ono. It which is an adaptation of a manga from the early 90s, late 80s, early 90s. It's basically telling the story of a bunch of nerds going to the Osaka art school, and in there you will find as called the creator of Evangelion, the early people that made the Gainax and all the other great like studios of the 90s. So it's hilarious. It's probably one of the funniest series I've seen. It's live action and it's it's so it's so funny. But yeah, it's called Aoi Ono, Blue Blazes. There's fan translation that you can find somewhere on the internet. I strongly recommend watching it because it makes you cry laughing. I think there are a couple of videos on YouTube as well about it. Let me see if I can find it. I'm not gonna show them, but I am, because I don't know what happens to the copyright. On Twitch. But it's super funny. 20th Century Boys? No, I haven't read it. I know it of it, but I haven't read it. I think I had. Yeah, no, I don't have the volumes, but I should. Oh yeah, we have a GNOME application to read comic books. Yes, to read mangas as well. Yeah, I have a couple of subscription on Comixology for stuff. Though to be fair, I still enjoy getting the actual paper, the Dead Tree version. For instance, I'm still getting One Punch Man delivered at home. I got the entire collection of Full Metal Alchemist in the 3 volumes per volume version. What else do I have here? Yeah, not much. So yeah, I went to digital first for most of my reading material because I moved house for a while. So I have, in 2015 I moved 3 times in 6 months because I sold my house, I bought a house, but in between selling the house and getting the new house and getting ready for moving in, we had to move, my partner and I had to move to a couple of in between a couple of places because it took like 6 months to get to buy the new house, and and then a couple of more months to get it ready for moving in. So after you move like 4 times, you kind of appreciate the fact that you don't have to lug around books and DVDs and everything else. Lots of comics as well. Not only you have to lug them around, you have to basically pack them up first, then put them somewhere, and they occupy a ton of space, and then you have to move them to the final place and unpack them and then put them somewhere, and suddenly you realize digital stuff, not bad. Of course, it comes with its own set of problems, but between physical and digital, I started to appreciate the digital a lot more. Oh. Yeah, it's something that happens. Yeah. Okay, so yes, that is true. It lets you lose weight and lets you move a lot. To be fair, I kind of let other people move this stuff most of the time. But yeah, yeah. That's why moving companies exist. Yeah, I tried packing up and unpacking myself a bunch of stuff, and I decided, after the first time, I decided, no, no. Oh yes. Oh, that is a fair point. That is a fair point. Yeah, the no, that's why I reserve. So, I mean, I'm not planning to move ever again. I might move at some point, and I'm already dreading like moving all the Goomplas from a house to another. It will be a complete disaster. I've seen what people do when moving that stuff. They basically prepare like plastic containers filled with packing peanuts and or like as called some fluffy material that you can carve out the shapes and put the models in. I'm not even gonna go there. It's going to be a complete nightmare. So hopefully I will not move. I will be buried in this house when I die. I don't want to move anymore. Hi, Rednov. Yeah. I kind of dread moving. I got too much stuff. I need to get rid of a bunch of stuff here. I still have a collection of DVDs that basically I built up over the years with like sales and stuff like that. And to be fair, they are not useful anymore. A bunch of that stuff should probably go away. So it's good every once in a while going over your personal collections and your audio possessions and stuff and clean up, you know, let go of some stuff. So hi, Chip Will. You have that too? Oh, good luck with the move. Good luck with your move. uh, oh. So, today I wanted to look back a little bit on the stack, on the GNOME stack, and work a little bit on documenting GObject. And in order to do that, I wanted to basically start writing some idiomatic GObject code that you would write if you were writing in C in 2022. Mostly because a lot of people ask, how do I start structuring my application with GTK and GNOME? So it's more a design question. Instead of asking like, how do I achieve X? A bunch of questions that I've seen on Discourse, on chat, on Reddit, and Stack Overflow are in the form of, okay, I can start with a template, but I also have no idea how to structure an application in GTK or in like using GNOME technologies. How do I design an application, not in terms of UI, but in terms of structure? How do I separate components? What are the best practices there? And it's true, we don't have a lot of documentation about best practices. A lot of people ask that because it's daunting being placed in front of an empty canvas. So you want to start with a good layout, a good structure, so you can build on top. And the usual thing you can say to people is open up an application and look at what they do, which is true. Let's not forget the fact that we are writing free and open source software for a reason, which is one of the 4 freedoms that free software gives you, which is the freedom to learn. And the freedom to learn is literally opening up an application and looking at how it's structured. There is a downside to that, which is kind of annoying, but it's there, so we have to deal with it. The fact that a lot of our applications are old and they are complex because they are already well established. So it's hard to see. You can see the forest, but if you want to know how the trees are laid down, then it can be hard to understand that. And newer applications are not often written C, so they're not often, and rightly so, they're not often written in a low-level language. The same kind of low-level language that we use in GNOME. So it's hard to understand how to put together things when looking at the end result. In other cases, applications are well structured, but the applications can be looked at and understood, but the problem is they are using older practices, like older approaches that have been replaced over the years or have been deemed less than useful. So the new idiomatic best practices are different these days, which is a fair cop. I mean, again, some applications in GNOME are old and they have been written over the past, I don't know, 15 years, 20 years, which means that what was idiomatic 15, 20 years ago is less idiomatic now, and any attempt at fixing that particular aspect is usually not as important as fixing actual bugs. Going back and fixing the design of the structure of your application is less important than fixing the actual bugs of your application. It would be nice to have a way to explain how to start. That's why we have the getting started tutorial, which tells you basically how to build upon the template, but you're building upon a template. So the template already exists. And the GNOME Builder templates for GNOME applications is good. There's a nice separation of components. You have the application object, the window object. You have the templates. All the data is isolated in its own directory and everything else. And it's, again, it's a good template. But as soon as you want to add more, you fall back into the how do I do that? How do I add objects? How do I add more functionality without knowing the best practice on how to do it? So I wanted to essentially give an example of that. Not by starting completely from scratch, but by building upon the template and figuring out how to go from the template to a more complex application. Well, sorry, not a more complex application. The application stays the same, but a more complex structure that is useful for future expansion on top of that. And yeah, I mean, that might be useful for people. That might answer the question of how to structure an application with GTK and GNOME and Builder. So let's go to the desktop. And here we are. So we are going to start with the text viewer application that I wrote in previous streams, and I used as a base of the getting started tutorial. It's already working. It's already the working version. Or at least it should be the working version. Yes, it is. So this is already the application that we would get at the end of the getting started tutorial. So we can build on top of that. Many tutorials on simple GTK application, but few on how to program with GObject. That is true. It's because the more generic you get, the more generic, the less constraint, the fewer constraints you put, the more generic you get, the less structure you can impose upon your documentation, which means that it's harder to write documentation if you don't have also a good set of constraints on top of that. I mean, for the getting started tutorial, we had a few constraints. We had the constraint of let's run Builder, let's use Builder, let's use whatever template we have, fixes notwithstanding. And then on top of that, we had to basically incrementally add functionality and features and expand on the base template. That is a set of hard constraints that allow you to write documentation that is easy to read. But a generic how do I start is so, I mean, it's daunting for people that are starting, but it's also daunting for people that are documenting how to start, if that makes any sense. So for that reason, I want to add a bunch of constraints here. So we start from an existing application that already has a bunch of functionality in there. And then we are going to build an internal API, an internal object that deals with a bunch of that functionality. So we can abstract it into, well, consolidate it from the widget tree, like we've just done, to an internal object. So, as I was saying, most of our functionality is implemented inside the window, the TextViewer window object. The TextViewer window pops up dialogues, opens up files, loads their contents, and put stuff in there, then maps window state to settings, and so on and so forth. And that is a perfectly legitimate way to start a simple application, because it removes a lot of complexities around it. And it does so by keeping locality of functionality. So you have a function that is local to the window, to the object that is manipulating, and you don't have to go, like, you don't have to structure interfaces or anything like that between components, because there is only one component. But this approach is kind of brittle. It is brittle because expanding the functionality, so if we wanted to add a new feature, if we wanted to add new functionality, if you want to add new state to save, then it becomes complicated to deal with that, because then you shove everything inside the window class, and it's not great. Suddenly you start thinking we should put everything inside widgets instead of putting everything inside state objects, and have widgets represent those state objects, which is the other way of doing this. You have a model that contains all your state and all your internals, and then you have views that represent that state in your UI. GTK is mostly designed for that use case. We have a lot of views and models inside our default API. But in general, it's a good way to structure your application. You have a state object and you have a bunch of views around it that display that state. So, for starter, let's start from here. Again, our plan is to go from a finished application, the text viewer, to the same application, the same sort of functionality, but structured a little bit better. So the window is not responsible for doing all the work. It's just responsible for displaying it, for presenting it to the user. Okay. So in order to do that, we are going to create a new file in our source directory, and we are going to call viewer file here. So text viewer file is going to be our representation of the file that we are loading, the current position inside the text buffer, inside the file, and then it's going to have a bunch of other ancillary data structure, ancillary data around it, but it's also going to be the object that is responsible for opening and saving the file. The actual operations, not opening the file dialog and selecting the file. That is still going to be part of the GUI. In this case, it's only going to be the actual asynchronous operation of saving and opening file. So we start with a simple pragma, and we start with including GObject. This is the usual boilerplate. Technically speaking, these two guards are not strictly necessary. They are only used to indicate that whatever is inside, is between them, is C API. So in case you decide to compile all of this stuff with a C++ compiler, then this one is going to be safe. Oh, hi. Oh, bye, Georges. Have a great day. Don't worry. So this is the boring bits of creating a GObject, which is the boilerplate stuff in the header file. Luckily for us, GObject has a bunch of macros that save us some of the time that we have to deal with. I mean, I could go on explaining what this macro is, but if you open the window header, you will see exactly the same thing. It's a macro that says that we are declaring a new GObject type. In this case, it's TextSphere window. This is the snake case prefix. This is the uppercase prefix, the uppercase prefix and name, and the parent instance. It's just, again, boilerplate. I can also explain what it is, everything that, what all of this is. Let's hear it. Oh, come on. Right file. I mean, I can definitely explain what everything is inside here. Can be a little bit boring, but so what we are doing here is we are declaring a type that is called TextSphere file. This stuff is not important. It's just stuff that gets used internally. The parent type of the TextSphere file is a GObject. That's all this stuff, this macro does. This one is another macro definition that creates that defines this symbol that is TextSphere type file, and it evaluates to calling this function. This function is what GObject does to register a type in the type system. So every time you call this, every time you have to use this macro, you're literally asking for the type to be registered. The first time you call it, the first time you use it, the type will be registered, and that's it. Every other time you use it, the type system already knows the type, and it will use that information. A type is just a reference to the type system, to the type information type system. If you print it out, it's going to be a 64-bit value on 64-bit machines, and it's defined at runtime instead of compile time. For the rest is literally exactly like registering a type, defining a type in C++ or in Python or whatever. This one is just fairly convenient because otherwise expanding this is extremely boring C gunk. So you don't, honestly, you don't have to know what it does. It's only interesting if you want to know how the type system in GObject works. But other than that, even it's in the documentation. I mean, let me find. It's literally in documentation. So, Claire, final. What it does is defined in documentation. So you can go on the API reference and you will see everything that it does. Other than that, it's not important. What is important though is adding API for that. So first of all, we want to add a constructor. In this case, we add an empty constructor. And then we add a text viewer file. So instead of adding GObject here, we want to add GIO because we're using G-file. This boilerplate makes kind of annoying to start GTK in C. It is true. It is true. It's kind of boring. In part is unavoidable. We are adding object orientation on top of a language that does not have object orientation as a language feature. So, but the other thing is, it's kind of a sneaky way of doing this, is pushing you towards using C only for libraries and not for applications. But yeah, it's a lot easier to use this kind of doing this kind of stuff in Python instead of, or JavaScript, or even Rust instead of doing it in C. In part because Rust, for instance, has a bunch of macros that are a lot better than the C preprocessor macros. But the main thing you have to do is accept the fact that the boilerplate is unavoidable up to a point, and then just go for it. Thanks for the follow, Asakaran. So we have two constructors here. The first one is this is the declaration, so no, we'll see how to implement them later on. But the first one we want is an empty file, and the second one is a file with another file. So you pass a G file and you get a TextVR file object back. Another couple of things that we might want to add are text viewer file open, and text viewer file save. These are not going to be how we implement them. We're going to modify the method because we are going to have to add some asynchronous. It's going to be an asynchronous set of methods, but it's going to work pretty much this way. So if we want to actually modify this, it's going to be something like this. And then we're going to have something like this. Text, viewer, file, open, finish. And then gr. And then the same thing will happen here with g cancelable, g async ready for that. And same thing here. Oh, sorry, this is going to be g async result. Otherwise, we won't have that. These are going to be our asynchronous operations for opening and saving a file. Since we want to update the UI at the end of the operation, we need to have them. We need to have an asynchronous callback there, where we call open finish or save finish, depending on the operation we're using. And after that, we are going to get to we're going to get the data out of it. But another thing that we want to do, no, we're going to leave it there. I'm not going to jump ahead. It's going to be, we already jumped ahead a little bit with the open and save functions. But yeah, we're gonna stay there for a little bit, and after that we are going to finish finish the integration later on, and we're gonna add API for that. So let's assume we just added the constructors here. Okay, these are the declarations, but we need the definitions, so we need to have the actual implementation. For that, we are going to need a source file that includes config.h first, and then includes our friend text viewer file h. Typically, the first thing you want to do is to add the config.h file, which is generated by the build system, and then the first header you want to include inside your C file, C source code, is the header file that is referenced to that. The reason why that happens is mostly for project hygiene. The overall idea is that your header file defines all the inclusion rules for everything that is defined inside your header file, and not more. So when you get here, everyone that includes this file will have all that is needed for that particular API. So you should include a bunch of random stuff beforehand, because otherwise you add an implicit hierarchy of inclusion, an implicit order of inclusion. And that is a bad idea, because then means you have to move, whenever you move around definition, types, or API, you have to restructure all your include files, and it becomes a mess. So we added the TextViewer filing header. At this point, we need to close the boilerplate loop. So the first thing is we are using the final type declaration. A final type is a type that cannot be derived. So it's a type that can be instantiated like any other type, except the abstract types. But it's a type that other code cannot inherit from. So you cannot have a derived type of TextViewer file. The way this is achieved in C/GObject is that this macro here defines the instance structure as this. So this one you would see if you expanded gdeclare final type, you would see this type def inside the expansion. This is an opaque type. Is a type that is a alias of this structure, of this definition here, this declaration, sorry, but it has no size. So you can actually use it as a pointer size, but you cannot know its size. And this is useful because we can hide the declaration, the definition, sorry. I constantly swap between declaration and definition. This is the declaration. This, sorry, is the declaration, but this is the definition. And the definition being inside the C source file means it's completely hidden from any user that includes the header file. So what we're going to do is define our object here. Now we're going to get in a little bit into the esoterica of how GObject works. So the first element of any types that is derived from GObject has to be the actual structure here, not a pointer, the actual structure. So we also going, this is why TextViewer file will not be derivable from the outside, because we don't have the contents of this structure in the header file. In C, doing this means that the contents of the GObject structure are placed straight at the top of the structure itself, of this structure here, the TextViewer file structure. It means that anything that allocates a TextViewer file structure will have the same layout of the GObject structure up until this point. Everything that follows is part of the TextViewer file. So it's going to have a G file here, for instance. But from a memory layout perspective, as long as you access everything defined up until this point, you are basically dealing with a GObject. This is how inheritance works in C GObject. So it means that you can pass a pointer to a TextViewer file to any API that accepts a GObject, and it will work, because from their perspective, they will only access memory up until this point, which is a GObject. GObject does the same internally for gtype instance, which is a structure that points to a gtype class, which is a pointer that contains the type of the class. So it's all nested down. But as long as you pass a pointer of this type to an API that expects a pointer to GObject, it will work. Every GObject also not only has a instance structure, but also as a class structure. The class structure would look something like this. Pretty much exactly the same, except it uses the class structure instead of the instance structure as the first field. But G, the declare final type, also it defines this structure here inside the header file, because it's perfectly safe to have it there. Since in order to do a derived type, you not only have to have the data type available for the instance structure, but also the data type available for the class structure. And if you only have the class structure, it doesn't matter. You cannot create an instance anyway. So when we added the macro to GObject, we decided to keep the class structure inside the header file because it's sometimes useful. But the instance structure is going to be hidden inside the source file. Again, all of this is kind of interesting as an explanation if you want to understand more about how GObject works. It's not really important on a day-to-day basis. It gets important if you, instead of using G declare final type, here you instead use G declare derivable type, because you're writing I don't know, an internal library, and you want to allow derived types of your data structure. At that point, you do have to do something like this inside your header file. Oh, come on. Your file class. So if you use a derivable type, you have to define the class structure inside your header type, inside your header file. But the instance structure will be also included in the header type, but will not be modifiable. And it will only contain, it will expand to this. It will only contain the parent type. So this stuff will be hidden by the macro itself. It will be generated by the macro itself, and you will have this to fill out in your header file. This is needed because what you want to do if you have a derivable type, 99.9% of the cases, is, and you have private, and you have data associated to the instance, which you should have anyway. The only thing that you can do is adding a private data. This is necessary for a very simple reason. If you are exposing a derivable type, you're exposing API. And the way the derivation works in GObject, as I've shown, is to add stuff to the instance structure. So is to add the parent type as the first type of your instance structure, which means that if your parent type decides to add a bunch of fields inside the instance structure, it will change the size of the instance structure, which means that every time you do this, your derived types will have to change size as well. This is what we call an ABI break, an application binary interface break. for instance, you're writing a library, you expose a type here, and you decide to add a field to the instance structure. Now everything that uses your library, uses the type from your library, will have to be recompiled, because as soon as you start running your code against a newer version of the library, it will break. So the thing that we do is very simple, is we don't allow you to do that. You can do it. You can do it in your own code. It's fine. Doesn't change anything. If you have full control of both the library and the users of the library, then it doesn't matter. But for actual libraries where API and ABI stability guarantees are important, then we kind of railroad you on the right track by removing the possibility of breaking API inadvertently. Is it better to start with a final type? Yes, it's always better to start with a final type. You can take a final type and make it derivable without breaking API or ABI. You cannot do the opposite. If you have a derivable type and you want to make it final, you have to break API. Which is the reason why most of the GTK widgets in GTK4 are final. That, and because we don't want people to poke at the internals. But yeah, basically the idea is start with final types, and if you're writing a library and you're exposing that those final types to other users, then they will be able to ask you to make those types derivable if they need to. But never start with a derivable type unless you literally have derived types inside your own library. So if you have inside your library, inside your application, whatever, if you have a type that is, for instance, a root type, and you want to have different implementations of that type inside your library, then yes, you will need to have a derivable type at the very start. But otherwise, starting with leaf nodes, so starting with final types, is always safer than starting with derivable types, because again, you cannot go back. You can only make a final type derivable, and you cannot make a derivable type final. The side effect of a final type, again, is that we don't need a private data structure. We only have access. We have access to the instance data without any indirection in between. So it's a lot easier to deal with that. If we made TextVR file a derivable type, we would need private data for the instance, which means adding a level of indirection in between. So you don't access stuff directly off of the instance data. You access stuff from the private instance data. GObject has a bunch of functionality and facilities to make that as efficient as possible, but it's an indirection. So once we declared the instance structure, now we can define the actual type. So now we are defining the type. We're defining TextVR file, again, snake case version for generating the functions. And then instead of using GObject like we did in the header file, this is the structure. Instead of doing that, we used the type inside the gtype system. Gtype object is the equivalent of text viewer type file. So it's a macro that really hides the call to the getType function here. In the case of GObject, it's not really a function, it's a constant value because it's defined at it's defined when we initialize GObject itself. So it's guaranteed to be a constant as soon as you load GObject, the GObject library. But the principle is exactly the same. So gDefineType works by requiring two additional functions that we've seen already inside the text viewer window and text viewer application objects that we modified over the past few streams. So the first one is the class initialization function. And the second one is the instance initialization function. I kind of glossed over these two functions when I was doing the getting started tutorial, because they're important only if you are actually implementing a GObject. Otherwise, they're just functions that get called automatically when instantiating a new instance of instantiating the type. I will refer to the GObject tutorial, but in general, the class init function is called once whenever you create the first instance of a TextViewer file here. So you create a new instance of TextViewer file. The first thing that gets called is TextViewer file class init, which will set up the class vtable, the structure that it identifies the type instead of identifying the actual instance of that type. So in this case, in this class init function, what you usually do is override virtual functions, like, for instance, the object class dispose. We've seen an override of a finalize function inside text viewer window here. Yeah, we use dispose, not finalize. Finalize inside the documentation, but it's the same. Dispose is the first function that gets called whenever an instance gets collected, when the reference counting goes to 0. So when you deallocate a text viewer, in this case text viewer window instance, it will first call dispose and then will call finalize. It's done this way to resolve reference cycles. It's a complex topic, and we're not going to cover that today, but it's another interesting thing about GObject being garbage collected that way. So in this case, we want to have a function called text viewer file dispose. Since this function is on the GObject class, it takes a GObject. So we need to cast it. Here. And then we also need to chain up to the parent implementation. Try function prefix with class name. I know, Gunibert. I want to write it down so it doesn't seem so magic. But yeah, I mean, I know that this the GNOME Builder has a bunch of snippets that let you deal with replacing stuff automatically. I know that it works that way, but I want to be I want to have as little magic as possible. I already have a ton of magic in the macros here for removing boilerplate. If I start typing stuff and text changes instantaneously, it gets really weird really fast. Right. Class does look a lot of German word. Yes. So this is something that happens when you have old school GObject developers like myself. So in theory, this file could be compiled with a C++ compiler. So it means that you cannot use class here because class is a reserved keyword in C++. So the way that this works is we use class. It's not required. I mean, I could literally just do this and it would work exactly the same and it wouldn't be a problem. It's habit. It's habit in GObject, it's habit in GIO, GTK, and everything else. But yeah. So also it feels wrong. I'm so used to it that it feels wrong using class here. so need to I need to change it because it gets me like makes my skin crawl. Anyway, so right. This is the dispose function. Again, it's the way we it's part of the finalization process for deallocating the resources of a object instance. In this case, we have a G file here that we are going to set later on. So for the time being, we are keeping it empty, but soon we'll have it. We'll use it to get rid of the G file instance. Okay. Outside of the class init function, we also have an instance init function. The instance init function is where you set up the initial state of the instance. So you set the all the things that the instance has to be at construction time when there are no properties, there are no other methods called, anything else. It's the initial state. In this case, since TextVer file doesn't do anything in initial state, we don't do anything. GObject guarantees that the instance structure will be set to all the contents will be zero field. So it's going to be, in this case, G file is going to be null and it's going to be fine. So if you don't have any initial state, you can leave this function empty. Now we have our constructors here. So we're going to copy them from the header file to the source file. And what we'll do is simply call GObject new. This one we're going to fill it out later on because it's not important right now. But this is essentially the way a constructor in GObject is implemented. You always call GObject new and only call GObject new with the type of the object you want to create and then a list of property names and property values terminated by null In this case, we don't have any property because we don't have any argument for that. And so we simply put null here. In order to make this work, we're gonna have to add it to our build system here. That's simple. We add the file here. So now we build it. Oh yeah. Right. I bet. Yes. It's namespaced here. I should have remembered that. So it's not config.h, but it's namespaced as TextViewer config.h. And that's it. Yeah, there are a couple of unused arguments here and there. It's fine, doesn't matter anything. But yeah, we added the source file to the build and it compiled. It doesn't do anything. So I would have been shocked if it had any other problem. But the overall idea is this one. You create this bunch of boilerplate here. GNOME Builder has snippets for that save you the time and will generate most of this stuff for you. But I wanted to show you how it worked. So let's add some more functionality here. In the header file, we kind of gave the idea that a TextViewer file contains a G file. So the path of the file that we are trying to open. In order to do that, we are going to add a property for TextViewer file. It would be super simple to have the implementation of TextViewer file like this. File new file. Sorry, new file is G file. And do something like this. Text viewer file price. Takes a reference on the file and returns res. So doing this is perfectly legitimate if you're an application. So if you don't expose this as a public API because you're writing a library, if you're not in that case, this is perfectly fine. It's not great, but it's fine. What you want though is not this, but it's this. Which is adding adding a file here as a property of the TextViewer file object. This is kind of mandatory for language bindings. So if you're writing a library that exposes a GObject API and you are going to do the GObject introspection dance of generating the machine parsable data that describes your ABI, having a C function that creates an instance and then sets a bunch of private fields inside it, no, it's heavily frowned upon, because your typical dynamic language will never call this function or this function. Even when you're doing something like in Python, like for instance, something like this. If you're doing something like this, you're not calling text viewer file new at all. This stuff is not that. You would be calling something like this, for instance, which is, it just doesn't happen. What you're really calling is GObject new. You're not calling this C API, you're calling this. So if you're calling GObject new, it means that everything, whenever constructing an object, everything must pass through GObject new. And the only thing that you can pass to GObject new are property names and values. That's it. Which means that we will need to add a property for that. And to add a property, we need to do a little bit of more of boilerplate. The first thing we need to do is declaring an enumeration with the properties. Is this necessary for a Leaf application? It's not necessary for an application. As I said, if you're writing an application that is only going to be called in C and like that, it's not important. It's not a huge deal. I personally find it not incredibly hygienic, but it's fine. It's entirely fine. You don't have to worry about it. Things change a little bit if you have an application that has plugins, for instance. And if those plugins can be written in Python or JavaScript or anything else, then you will need to consider your internal API as an API, as a library API, which means that in that case, you will need to obey to the same kind of rules that a library has to follow. So, but yeah, for an application, a mere application is not important. Again, it's in this case, it's a personal preference, and I'm writing this as an example of idiomatic GObject code that applies to both applications and libraries. So, yeah, the reason why we use an enumeration here is because we need to pre-declare an array of object definitions. Let's say file props, like this. This is GObject boilerplate. Sadly, it's needed. I haven't found a way to get rid of this, and I've been trying for the past, I don't know, 10 years ish. It's so complicated and you have no idea. But yeah, let's just say this is needed. This is part of the boilerplate needed for declaring object properties. So the first thing we have to do when declaring, if we want to use properties, we need to define the set property and the get property, virtual functions, override them. Object properties, well, GObject properties are multiplexed from within the GObject class itself. So the way it works is you define what a property is. So in this case is an object property, and it's called file. and you specify the type of the object that this property is going to have. So in this case, it's going to be gtype file. And then we specify that it's writable, readable, and will explicitly notify when there is a change. And also the strings are static. Static strings. So we want a writable property, read-write property that will explicitly notify on changes, and the strings that we're passing here, in this case just file, are going to be static. So they are in static storage and they're not going to be copied into gparamspec. And then we tell gobject to install those properties. So as you can see, properties are part of the GObject class. They're not a concept that exists inside the type system per se. They are part of the class itself, which is not great, but yeah, it's what we get. Now we have to implement the set property and get property. As I said, these functions are multiplexers. So you have a single function that takes a GObject and takes the property ID that you're setting and the value of the property. You also get past the property definition, the object that defines the property. So every time, even if you have like a bajillion properties attached to your GObject class, it will always, setting 1, setting 10, setting all of them, will always call the set property virtual function. So the thing you have to do is switch on the property identifier. The property identifier is this in this case. Install properties will take this case properties here. The install properties will use the array that you define here. The first element of the array is going to be null. It's going to be 0 because the array starts at it's probably easier to see if I do this. Okay. This one is going to be unused because 0 is a reserved slot, a reserved identifier. So instead of doing this, because it's boring, we tell the enumeration to start at 1, but we allocate an array of gparamspec objects using n properties, which is going to be 2. So it means that this array has 2 slots. The first slot is empty, and the second slot has the file property definition. So we are here. And then we do this. So what we're doing is we're going to call a accessor, well, a setter file, which we currently don't have defined, but I'm going to define it in a second. And we're going to pass the instance that we get from GObject, and then we get the object is stored inside the value. GValue is just a generic container of data that lets you assign a type to the data you're containing. So since we used gparent_spec object here, we need to do gvalue get object here. Then, since we are good citizens, we have a default we have this simple macro here that basically every time you get a property ID that doesn't match one of these, it emits a warning at runtime. This is strictly speaking entirely unnecessary. It just cannot happen. If something like this happened, it meant a gaping bug, a bug of gargantuan proportions, and it would be nothing would work. Let's just say that nothing would work. It's just a good case, a case of good hygiene to include it as a safety net, but it's strictly speaking completely unnecessary. Just like we did the set property, we're gonna do the get property. Get property is precisely the same, except instead of getting the file from the gvalue, we are going to set the gvalue with the file instance. Behavior is exactly the same. So we don't have a public accessor there. So we are gonna need to add one here. We're gonna declare one here, and then we're gonna add it here. So in our accessor, we are not going to do anything incredibly special. So we are going to use this set object self file. This macro is provided by GObject itself. It's not really a macro, it's an inline function, but it's basically the same. Essentially what it does is, if the object at this location is not equal to the object we are passing, then we unref, we drop a reference on this object and we replace it with this instance and we acquire a reference. And if this swap happened, then we return true, otherwise we return false and we bail out. So in this case we use this to notify that the property has changed. So whenever we call setFile, what we do is we replace the file inside the instance of the TextViewer file with the new file. And then if that happens, we notify. This one will emit, this function call here will emit the GObject notify signal, which we use to do things like property bindings or gsettings bindings, for instance. So now we need to go back to the dispose function, and if the file is set, we clear it. This will drop the reference that we owned, that we acquired on the file here. So let's see if this builds. Yeah. Typo. It's not file, but it's value. Yep. And the build succeeded. So at this point, we have the TextViewer file class that has a single property called file that contains a G file. And we have a constructor that tells you that creates a typeviewer file instance with setting the file, and an accessor function if we need to change the file name, the file. And that's really it. Okay. We also can add a simple accessor, a simple getter function. This. That immediately returns a pointer to the file here, and we can declare it. Yeah. So we are okay. I freaking hate this warning here, so I'm going to do this. Right. So how do we do that? How do we deal with this? What is the purpose of this? Well, for instance, we do this. We can do this. Let's call it. Let's rename it a little bit. A couple of things. So it's not. It's less unclear. It's more clear. So, for instance, in this case, we do this, and then we do so in our text viewer window widget, we open files and we save files, which means that the window has a file associated to it. And if it has a file associated to it, we can add it here. It means that the window will always have a representation of the file. It's either an empty file, so the window is empty, or it has a file that we just opened. So whenever we open a file, we get the file from the file chooser, and then we do something like this. Self file equal, sorry. So let's go back inside the instance initialization function here. So a window has a file. It means calling text viewer file here. This is the file that we are going to modify, and we'll also need to clear it here whenever we clear and whenever we open a new file here, we call text viewer file set file. So it's not entirely useful right now because we operate on temporary files. But still, at some point, we will remove this. We'll move all this functionality inside TextViewer file. If we want to know that something has changed, we can do something like this. Connect self file notify file. Just like we get a notification on the text buffer whenever the cursor position changes, we want to get a notification whenever the file changes. So we need to add a function for that. We can add it a little bit lower here, for instance. Okay, the text viewer file is this one. So whenever it changes, we print out the new file path, for instance. File text viewer file get file. That's it. Okay. The unused parameters, it's fine. Okay, so we run it. We open a file. And here we go. We got a notification that we have a new file opened. Okay. So now we moved the state of the file from the window widget to an ancillary object here called TextViewer file. We added a property there, so we get notification every time the file changes. So for instance, if we open a new file, and we go into projects, text viewer, source, main, the new file that we loaded is available there. So it opens itself. And so on and so forth. Every time we open a new file, we'll get a notification that the file has changed. So what other properties we can have? Well, for instance, we have the properties of the location inside the file. So let's add more properties there. So property line and property column. Here we go. Props line. In this case, it's going to be let's use uint 60. No, it's going to be I need to check the documentation for that. Later. Get line. It's an integer value. Okay, so we are going to use an int. The minimum line is going to be 0. The maximum line is going to be the maximum integer, and the default value is going to be 0. And it's going to be a read-write property. Yeah, we can add an explicit notify. And static strings. And then we add file props, column, again, it's gonna have a range from 0 to max int and a default value of 0. It's gonna be read write, explicit notify, and static strings. And then we are going to add the setter for this properties. We need a C function. Now let's use the in this case we don't use a C function because we are going to use a single okay, and the getter is going to be this. Line. And column. We are also going to need to add the fields here. Line and column. So one of the things that we've done inside the window is keeping track of the cursor position. In which case we are going to do this. Self file line is going to be GTK text either get line. Let's do it a little bit better. Line and column. So we are going to do line is GTK text either get line +1. Column is going to be GTK text either get line offset +1. So at this point we can do line and column in a single line. But now we store this information inside of our state tracking object. So we don't only store, we don't only present the user the information using this, but we also store it inside the object. And this will come in handy when we decide to store this information inside G settings so we can save state. Yeah. So let's see. Oh, we'll need to do. We don't need to do explicit notify here because we don't have an explicit C setter. We rely on using GObject set, and GObject set by default will emit the notify for you. So if you're calling inside your set property, you have two options. You can call the public API, which should always call GObject notify or GObject notify by pspec. But if you access the fields directly, so you don't have a C accessor function, then you don't want explicit notify, and you want to have GObject set always call notify for you. The reason is historic. Well, it's partly historical. It's partly is to fix kind of a miss feature. So GObject set will always call notify, will always emit the notify signal for you because it cannot compare the previous value with a new value of the function. So it cannot know that the value was effectively changed. So we'll always emit the notify signal. But inside your C function, inside your C setter function, you will only emit notify if the value of the property has effectively changed. So let's assume that inside the set property you call the C function, and the C function detected that the new value is exactly the same as the old value, so it will bail out. It will still emit a notify signal without explicit notify because GObject set always emits notify. So if inside your set property you call the C API and the C API does a check and bails out if the two values are the same, then you must always add the gparam explicit notify flag to the gparam spec object, gparam spec definition of the property. This way you don't emit spurious notify signals. And this is especially useful if you're gonna use G object bind property, or if you're gonna use G settings bind, because then you interrupt potential cycles. Let's say you have property A on object A bound to property B on object B in a bidirectional binding. It means that whenever you set A, you also set B, and whenever you set B, you also set A. The only way to interrupt the cycle is to verify that whenever you set A to the same value, you also don't emit a notify signal. So you always have to make sure that the your property setters do a comparison. Okay. Right. So at this point, we have an object that keeps track of a bunch of state there. We could, in theory, instead of updating the label here using the cursor position notification, we could use the line and column notifications. It would be it would make sense if it. So right now we have a single label that has the line and the column as a single message. If instead of that particular layout we had a box with 4 labels, one with the line and one with the line number, one with the column and one with the column number, then we would be able to connect to line and column and bind the text there directly. So we would be able to modify only one label instead of modifying both, instead of modifying all the entirety of the label whenever the line changes and the column changes independently. So if the line and the column change independently, then we can independently modify a single widget. It's kind of complicated, and I don't want to do that. It requires changing the UI. But for instance, it makes the numeric so it would look something like this. It would look something like this. Child. We're going to remove those in a little bit, but it would look something like this. So okay. Come on. Let's see this. Then we would have something like this. So we could remove this here and here. We do a little bit of spacing. we do something like, I don't know, 4 pixels. So instead of having a single label that does everything, we have 4 labels inside a box, and we have 2 labels that are going to be modified. And instead of doing this, we do something like this. Line. The target is going to be the self line pause. It's not exactly like this. We're going to have a little bit of a tweak there. So we are going to do something like this. Label. This is going to be the GTK box. Line pause. GTK label. Column pause. I didn't expect to do this, but I will do it anyway. Okay. So we'll have to change a little bit here. It's going to be since we want to bind this to so it's going to be this. Since we want to bind this information, the location on the file to a label, we are going to have to store the stuff. Instead of using an integer, we are going to store it as a string. It's not strictly speaking necessary. You can do transformations, but in order to do transformations, you have to do a few additional tricks. So instead of using this, so now line and column are not integers as strings. So instead of doing this, we have to do something like this. Value. And we need to free the line. And we're going to go here. Instead of storing them as integer, we store them as jar star. So we also need to free them. Let's use gclear pointer self line. Oh, come on. Okay. And then we have to change them here to be set string. And here, instead of using gparm spec int, we're going to use gparm spec string. Since it's a string, we have null as the default value and not a range anymore. And that's it. So this one should compile correctly. Okay. So what have we done? We've changed line and column from being integers to being strings, because now in here we bind the line and column properties of the file object to the line and column widget that we define inside our UI. We also need to add them to the template declaration. So let's see what happens. Everything falls apart. Right. Yeah. There is no text, of course. It's label. So if we open a file here, there you go. So as you can see, the mechanism is exactly the same. But now, instead of having this one as a single label here, it's really 4 labels. 2 of them do not change, and 2 of them change here and reflect the position of the cursor. The position of the cursor is changes are done by storing the location of the cursor inside our state tracking object here. So the text buffer notification will update the state tracking object, and the state tracking object will then update the 2 labels that we use here. Okay. Why this is useful? So this is going to be useful in a while when we do. I don't know if I'm going to do it for this session here. Maybe on Friday I will probably finish on Friday, because I can feel the brain melting. I can already feel your brain melting. The overall idea, the end goal is going to be storing the file and the position of the file, position in the file, inside the settings, just like we save the default window, the window width, and the window state. And this is going to be useful when we reopen the application, and we will reopen the last open file, and we'll restore the position of the cursor at the last cursor position, which is kind of what the GNOME text editor does. So it's a simple way to do that. In order to do that, though, we need to implement the open and save file as well, and then bind all the properties there. So let's try and do this. Let's re-implement open. So open right now in our text view, a simple text viewer, is called as a response to the file selection dialog, having chosen a file. So we set the file, and in theory, we should open it. So if we do this, we can do this. Text viewer file open file, and then we have null cancelable and gsync ready fallback open file complete and self. So we don't call this function here. So this is going to be moved inside the TextViewer file. So let's already copy this and move it away. I'm sorry. So the result is going to be this. Okay. So we need to have an open method on our TextViewer file that will do the content loading and then will also load the display name and will also update the buffer. So instead of all of this, we can add API for that. Like for instance, we can have this. Do we cache it? Yeah, we cache it. And char text viewer file get display name. And then we can have a function that returns the contents, for instance, of the file. So they get cached. Or one thing we can do instead of doing that is yes. So we already have a model there, which is the text buffer, the GTK text buffer that we use here. There is no reason whatsoever why the GTK text buffer must be the one provided by the GTK text view. Right now we get the buffer here from the text view itself, but it's not strictly speaking necessary. For instance, the text viewer file could provide a text buffer by itself. So this is useful. We need to modify the import here. This is useful because then the text viewer file object, whenever we open stuff, will update the buffer internally. So the window, instead of using GTK text view get buffer here, will get the buffer from the text viewer file. We'll connect the same callback here, but we'll also do GTK text view set buffer. And we'll store it, and we will bind the text buffer to the text view. Okay, so we need to add GTK text buffer here. And in theory, we could move all the line and column like handling directly inside the text view file, and so on and so forth. That would be also be entirely possible and would be pretty easy to do now. Self buffer GTK text buffer new with a null tab table, and then we need to clear the object when we clear the file. And there we go. So let's see if we can go back a little bit, and then let's not do this now. Want to try first, so we can still do this here, and then we comment out this part. Open now complete. Okay, yeah, I didn't implement that function. Okay, it's gonna be GTK text buffer text viewer. Oh, yeah. Right. So nothing should have changed at this point. Yeah, nothing has changed. Now the buffer though is stored not inside the text view, but it's stored inside our file object. And we share it with the text view. So in theory now we can also do this. We remove this function here and we move it inside this. Okay. Okay. Then we go here, the cursor position, and we remove it. From the window. Text buffer. Notify cursor position. And this is going to be text viewer file. We have everything we need here, and we modify our own properties there. Of course. Buffer undeclared. Why? Oh yeah. Itself. Buffer. Okay. Run it. and it should work exactly the same as before. Yep, works exactly as before, but now all the functionality is inside the state tracker object here. Let's make it a little bit less long here. Yep. And now we have the window does fewer things. Like the cursor tracking is not really the responsibility of the window anymore. It's the responsibility of our state tracking object. And since it's the responsibility of our state tracking object, then everything goes there. The only thing that happens inside the window is that we bind our state tracking object to the UI that is held, the widgets that are held by the window. This way, whenever the state tracker changes its internal state, then the UI reflects that change. And this is kind of, I think we're gonna stop here because it's kind of it's getting late, and again, I can feel the brain melting through your ears because it's a lot. And I understand that it's a lot because it was a lot when I started working on GTK. So let's go back to my big head. So one of the important parts of how to structure a GTK application, how to structure a GNOME application from scratch, is trying to remove as much information as possible from the widgets themselves and into state tracking objects. All the business logic that you need, all the business logic you have to create to manage the functionality of your application should be confined inside those type of objects, those state tracking objects. You might call them state tracking object, you might also call them model objects. These objects maintain all the state that is necessary for the application to work. At the other end of the line, you have view objects, you have widgets. Those widgets do not maintain any state internally. They only display what the state object currently provides. And in order to do that, you have functionality like the property bindings and the settings bindings that we just that we used inside the text viewer demo application. So the way the people start writing their application first is to cram as much as possible inside the widgets because it's easier to keep state in there. It's easy because widgets already provide a ton of functionality to know that the state changed. All the signals, all the properties, everything else. It's really easy to start with that. But at that point, the application becomes harder and harder to maintain and to update. Adding more functionality, adding more state usually ends up breaking the widget, the everything inside the widget kind of approach. So the first thing you do after writing an application that is widget oriented, that where all the state is contained in widget, is to try and extract all that state from the widget into a separate object. It's easier if you do not do that and you start directly from the state tracking object. So you start immediately by defining what kind of state you're going to track. In the case of a text viewer, you're going to track the the file you've just opened, the cursor position, and in the future we'll have more information there. But I understand perfectly the first instinct is to stick closer to the widget view of things. So adding functionality inside, so taking a widget and subclassing it and then adding all the functionality there. Ideally, you would not need to do that at all. Ideally, the widgets stay as neutral as possible and they just present that information. And whenever widget changes, so for instance, you interacted with it, like, I don't know, you press a button or whatever, then you modify the state tracking object. And modifying the state tracking object on the other hand, will automatically update the UI with that information. So instead of having everything inside a widget, you end up with everything inside a state tracking object. And the advantage of that is that adding more functionality to the state tracking object is usually a lot easier because the state tracking object is simpler. It's not part of a complex hierarchy. It doesn't have some intrinsic functionality by itself. It's just data storage. And probably some business logic to move from the data storage from in one state to data storage in another state. The way that works is that at the end of the day, whenever the state changes, you update, you emit a signal. In this case, in most cases, it's going to be a property notification because it's easier to use with other parts of the GTK API. As you've seen today, we bound a property on the state tracking object to a property on a GTK label, which means that every time we change that state tracking property, the label gets updated automatically by itself. So it's a lot cleaner and it's a lot easier. But another advantage of that particular model is that you can easily swap it out. Let's say you have another state tracking object, or you have an application that has multiple possible states. Then instead of having to swap out the entire UI, you can swap the state tracking object. And you can map it to different top levels as well. So if in our case the text viewer application had multiple windows open at the same time, every window will be backed by a separate state tracking object, at which point the state tracking object can save its own information there, its own state, like the current file, the current position in the file, inside a more complex data structure. And you don't have to keep track of all the windows by yourself. You only have to keep track of the state objects. Again, this is done in a way so that the complexities do not escape the actual business logic, and you don't have to deal with GTK widgets. GTK widgets are complex. GTK widgets have inherent functionality that is there for a reason. It's there because GTK needs it. For instance, some GTK widgets cannot be derived. They're final widgets. They're final types. You cannot create your own subclass of those widgets. One way to work around it is to create your own custom widget that contains that widget that you want to derive inside it, but it's a mess. It's a lot of code for no advantage. Instead of deriving a widget to add your own state there, create a state object, create your own model object, and then have the widget be the view. so represent that particular state. So the structure of your application sorry, I'm talking in absolutes, but talking in absolutes it's tricky at this point. So the best practice for writing a GTK and GNOME application is to have a state tracking object as the core of your application. The state tracking object represents the data structure that you want to manipulate, that you want to represent. It will contain all the business logic that deals with state changes and contains all the business logic that deals with, for instance, storing and restoring that state into permanent storage. Then you have your UI that represents that state. So a complex structure of widgets that will be updated whenever the state of the model object changes. This is, I think, the best practice for modern GNOME applications to follow. Sadly, it's also not the model that we used in the past. So it's kind of complicated to open up an older application and see that design in actual use. But on the other hand, a lot of the older applications that have survived up until now will very likely have a similar structure, because it's the only way that we have to ensure that applications can be maintainable for a very long time. So you will only see abandoned applications or very hard to maintain applications, so applications that do not get released often, or they're very simple in nature, to be a jumble of state and state representation, instead of having clearly separate domains of state, of models and views. I don't want to make sweeping statements here, because there is enough variety in the free software world that I can find any example that confirms or completely obliterates my thesis here. But for newcomers to the GNOME platform, I strongly recommend this kind of layout. Structure your application using state objects as models, and use your widgets as views. GTK4 itself kind of nudges you fairly heavily. So it's not a nudge, it's literally being shoved towards this kind of design, because it's the only way we found to make applications maintainable in the long term. I mean, for a one-off, you can throw together a Python script that measures, I don't know, 100 lines, 200 lines. That is all like jumbled together. It doesn't matter. But if you are planning on maintaining your application for a while, then you probably want to structure it this way. Hopefully it made sense. So theoretically, yes, this should be if not easy to follow, at the very least easy to sorry, if not easy to understand, it should be easy to follow as literally a set of instructions. But I think it's also understandable to the point that it can be followed for new applications. But of course, if you have comments about it, then feel free to leave them in the comment section on my YouTube channel when I upload the VOD this tomorrow. Because I'm kind of interested in other perspectives, and I say this in all seriousness. I'm kind of interested in other perspectives for this, because it's kind of it's a design question, it's an architecture question. So it's not a series of strict rules. It's a conversation between various parts of the platform. So GTK has gone from being very almost procedural in its design, so series of steps that you can just shove literally inside your main function, to initialize the toolkit and build the entire UI and then connect to signals and then spin your main loop. And we moved away from that design towards a more, here's your application, the application gets instantiated. When it's instantiated, you create a window, and when the window is created, then you listen to changes on there, and you have a bunch of model objects, you have actions that get activated, you have widgets that activate actions and then are activated by actions. So GTK kind of has chosen its design and its direction in terms of pushing people towards that particular kind of design. But it's not entirely, it's not an entire done deal. There are other libraries and even other languages that put this kind of design, like they punch it up to 1,000,000. If you go on if you go and look on web design, you have Elm, for instance, or the various JavaScript frameworks for model views. In Rust, you have Realm, for instance, which is a similar kind of approach, where you have strict model objects that update a UI, and there is a very strict separation between the core business logic that doesn't touch anything related to UIs, and UIs that are representations of that core business logic. But also you have, as I was saying, like scripts that can run an application and in 100 lines of code and do whatever. So I think, from my perspective, at the very least, the current most idiomatic way to approach this is to use model views and controllers, incorporate them inside your design for your application as a fundamental architectural tenet. But who knows? Maybe there will be something new in the future, so it could be very different in 5 years' time. And we'll have to adapt to new best practices and new APIs in the future. I guess the end result of this particular kind of like GObject tutorial slash architecture tutorial is going to be a list of best practices that we can use to teach people, well, less teach people and more direct newcomers to a better understanding of our platform. Who knows? Maybe not. But yeah, I'll Yeah, on Friday, I will finish this by moving everything inside the state tracking object, and then I will add the session saving and restoring to the text viewer. We'll have to clean up a couple of bits, but other than that, I think it's going to take a couple of hours for on Friday. So we'll close the week with a new version of the text viewer application, this time with a new feature, a deeper state saving mechanism, but also a different architecture. And we'll see what happens. We'll compare the older version with the new version and see what happens. So if you have been following up until now, congratulations. I'm surprised. It was a lot of information, and I apologize for that, but it's a lot of stuff, and there is no way around it. If you want to follow me on Twitch for whenever I stream on Monday and Wednesday and Friday, so you can see me doing this stuff live, then it's great. If you instead want to subscribe to my YouTube channel to watch these kind of tutorials more at your own pace, then you can do it. Leave a comment and press the like button and subscribe to my YouTube channel, so you will see the VODs as soon as they land. And hopefully the all-knowing YouTube algorithm will be able to present to you these tutorials as soon as they are available. Other than that, I wish you had a great rest of the day, and I will see you all on Friday for the next stream. Bye.